Select the major product of the following series of reactions. So if we look at our starting material, we can see that we have a benzene ring, which we actually have not talked about the chemistry of yet. And I will tell you that this chemistry does not affect the benzene ring, although you can probably guess that by the fact that it is intact in every single one of these possible products. So we're not going to react the benzene ring, but we do have an alkene. And so this is where our reaction is going to start. So we see that we're taking an alkene and we are treating this with aqueous acid, so H3O+. So hopefully we recognize this as acidic hydration of an alkene. Right, so your alkene will react with the acidic hydrogen. Right, so this is a reaction that you would have seen in the first semester of organics. So you're going to get a carbocation, and it's going to be the more substituted carbocation. So here it's going to be secondary and benzylic, so it should be really stable. So that's where you're ultimately going to have the water that you're generating here come back and attack. So you're going to make the more substituted alcohol out of this first step. So you're taking your alkene and you are making an alcohol. Okay, so there is the alcohol. So that's a product of the first step. And then in this second step, this is hypochlorous acid at 0 degrees. So this is an oxidation. So we saw this back in the chapter on alcohol. So this is a mild oxidizer. So this would take a secondary alcohol like we have here and form a ketone. If you had a primary alcohol, it would give you an aldehyde. So we have a secondary alcohol, so we are going to form a ketone in this case. So we went from the secondary alcohol to the ketone. All right, and so now in this last step, we see MCPDA, which is a peroxy acid. And so in the first semester of organic chemistry, you got used to seeing this taking alkenes and making epoxides. So if step 1 and step 2 weren't occurring, you could go from this alkene to this epoxide. But we did do step 1 and step 2, so we no longer have an alkene, we have a ketone. So you need to recognize what a peroxy acid does with a ketone. And this is a Baeyer-Villiger oxidation. Okay, and so we looked at the mechanism in a previous example, and we said that this is going to insert an oxygen to give you an ester, and it inserts on the more substituted side. So it's going to insert between the carbonyl and the phenyl group. So you are going to make an ester, inserting that oxygen between the carbonyl and the phenyl group. So this is the ester that we're going to end up with. All right, and if we take a look at our options, we can see that that is C.